When you start to have your design, you then might want to create prototypes. So what is a prototype? A prototype is the original or model on which something is based or formed. It's a mock-up or a simulation. So it's when you go from taking your design, which may be, there might be sketches, there might be a conceptual model, but you start to actually make that into a thing. So why do we prototype? It allows you to explore and evaluate design ideas in even more depth than something like a storyboard or a use case would allow. It allows you to communicate ideas. It allows us to understand existing users in context. It allows you to get started on the actual system building and figuring out all the different components without actually building the whole thing. There are certain principles of prototyping that are important to actually creating the right scope or lens for your prototype. The fundamental prototyping principle is that prototyping is an activity with the purpose of creating a manifestation that, in its simplest form, filters the qualities in which designers are interested without distorting the understanding of the whole. So you might look at the form factor, you might look at the visual elements, you might look at some of the conceptual layouts of your hierarchy of web pages, for example. You might build a prototype for each of these or a prototype that incorporates some of these and not others. And the reason that we do a prototype rather than fleshing out this whole design is both to create that filter to focus in on certain elements and because you want to save time or money. The economic principle of prototyping is that the best prototype is one that, in the simplest and most efficient way, makes the possibilities and limitations of a design idea visible and measurable. So that's a whole lot of text for you. A way to look at this another way might be that prototypes can tackle different qualities, aspects, or sub-problems of your design. So if you're building a functioning product like a camcorder, you might try to explore the form factor. So you have a 3D form with a hand strap. You might 3D print this, or you might take some plastic that you have lying around your shop and construct the form factor, put a handle on it, and get a sense, okay, this fits in your hand, but if it's bigger or smaller, it doesn't quite work. And that examines the ergonomic quality. That's one lens, and it's the most efficient way of looking at that aspect. Then you might make a screen-based viewfinder and interface panel, which allows you to kind of mock up looking through the camcorder or like looking at the screen that's on your camcorder and a set of buttons that you can interact with. This lets you examine the input feedback relationship quality. So, when you change something in the button, what changes in the viewfinder, but you don't actually have to build that physically. And then you might do a 3D form with partially working breadboard. So you might examine the input layout quality. So once you have an idea of the different widgets that you can prototype in software, you may then prototype them in hardware, plug them in, and compare different buttons when they're physically on the 3D device, which allows you to examine that. All of these prototypes get at different aspects of the design, and they're one of the simplest, most effective ways at looking at that particular kind. You can also mix and match different fidelities. You can take a prototype and mix it with something that is closer to the final product, a phone case. So you may have all these different, popsicle sticks and paper with writing on it to try and prototype something very, very quickly. And then you may have someone hold the physical phone. You can kind of mimic what's going on. And we'll talk about that when we talk about paper prototyping. But before, we should probably talk about the word fidelity, since we've mentioned this a few times in this class. So let's make sure we understand what it means. Fidelity can range from low to high fidelity. And at the low fidelity, you might have something more like a sketch or a paper prototype. At medium fidelity, it gets closer to the final product. And then at the high fidelity end, it's very close, or at least appears to be very close to your final product. We can define fidelity by saying it's the amount of functionality and performance relative to a final product. When you're in early on in your design, you might start with low fidelity prototypes. So you brainstorm representations, you try and, again, do these funnels. You try and explore lots of ideas and start to narrow down. When you're starting to narrow down, you start to flesh out a fewer set of candidate ideas. And this is where you can fine tune. You create something that's a little bit closer to what its final instantiation might be. And then finally, you get to your high fidelity prototypes, which allows you to do some limited field testing or alpha beta tests, which then actually can become working systems. You can do this with any interactive system, even robots. This is a robot called the Cuddlebot from UBC. It's a breathing robot that is meant to calm people down, for example, if they're worried about, if they're anxious about surgery, or if they aren't able to have a pet of their own. It might help them, relax and stay calm. The problem is this device was really expensive to build and prototype. It was a full working robot. It took a long time to build, and so it was really challenging to figure out whether it did the thing that it was supposed to do. And once it was built, it was really hard to change because you had already built a robot. So instead, you might do something like this. So here, you see there's this prototype that's looking at the different ways that things might move in a variety of low fidelity ways. You start to get to something more medium fidelity where you're putting a servo in there and controlling with an Arduino. You add some fur, so you've got the lens of like material and of shape and of motion. You might start extrudating things manually again. And eventually it starts to become a little bit higher fidelity. It resembles something closer to a set of ribs that could be a final robot. And then you could put something over that to have it actuate. You might take another approach. This is a second set of family of cuddle bits, which allow you to prototype things. So starting by exploring materials, seeing what moves in what ways, also what it feels like, exploring these different materials, and then you start to look at the motion once you kind of conclude. And so as you continue to explore, you might look at different materials, incorporate them into what you're doing, and you end up with this sort of breathing machine that is actually kind of squishy, using these little like binder bookends, and it allows you to create these little tribble-like creatures. So this is a super cool project led by Paul Bucci at UBC, and it allows you to rapidly sketch the different fidelities, different aspects of this robot. This is especially cool because it's all open hardware. You can go and build your own custom cuddle bits. And if you want to do this, I absolutely invite you to go check it out online. And of course, it doesn't just stop at building the actual physical thing. You might want to design its behavior. And so this is one project I'm really happy about. I worked with Paul Bucci here, David Marino, and Carrie McLean from UBC. At prototyping how these behaviors might actually happen in a way of making puppetry really easy.
We present Voodle, vocal doodling to sketch effective robot motion. When describing something abstract like motion, many people may find themselves at a loss for words and may opt to use non-word vocalizations to express themselves. Voodle translates the properties of your voice into motion on a 1 degree of freedom robot. Voodle detects features like pitch and amplitude and interprets them according to a set of user-definable parameters. With Voodle, users can quickly and naturally sketch effective behaviors in a unique conversational design space.
I love this project.